Alright, so in this problem we got Kuko here, who is throwing a balloon from an 80-meter height onto Peppo's head, who has a dart gun on top of his head, of which he's gonna shoot a dart to the balloon and pop it. So what we're asked is, at which time does the balloon pop, and how much time does Peppo have after that to get out of the way? Alright, so first we're gonna find out at which height is the balloon falling when Peppo throws the dart, because Peppo throws the dart at a time of 2 seconds. So at 2 seconds the balloon has already fallen a certain distance. So we substitute 80, which is the height, minus gravity times the time squared divided by 2, which equals 60.38 meters. And then we're gonna do the speed for the balloon at this height, because it's been falling for a while, so it's already accelerated a little bit and it's already got a speed. So we're going to use the formula of final velocity equals initial velocity minus gt. So we got final velocity equals minus 19.62 meters per second. It's going downwards because our reference point is going upwards. So then we have to write the equations for when we already know that time equals 2 and Peppo has already shot the dart. So for the dart's case, we got 20, which is the speed at which it's being thrown, minus gt squared divided by 2, which is part of our cinematic equations. Then for the balloon's equation, at time equals 2, we got y equals 60.38, which is the height, minus the speed times the time, minus gt squared divided by 2. As you can see, we got this term exactly the same in both. And this is important, because now we're going to just equal these two equations in order to know at which height, in order to solve the time. And if we equal the height of these two equations, it means that they are at the exact same height, alright? So we're gonna do it. We can first of all cancel this term and this term out, because we are equaling them and they are gonna subtract each other. So we got 60.38 minus 19.62 times t equals 20t, alright? So then we can do the math, just pass this onto this side, then divide 60.38, and we get a time of 1.52 seconds. You can check this in your calculator, and we add the 2 seconds that had already passed, and we get a time of 3.52 seconds. So this is our point A. At this time is when the dart hits the balloon and the balloon pops, alright? So next up, the problem wants to know at which time, how much time does Peppo have to get out of the way before the water hits him? So to do this, the only thing we have to do is substitute in this equation and know the total time. Well, substitute in the original equation, which I'm going to rewrite now, and know the total time that it takes for the water to fall from the very height of the building to the floor, and then subtract it to this time. And that will give us the time that we need, alright? So, what we need to do is the final speed, final height, which equals 0, because we're talking off the ground, of Peppo's head actually, equals 80 minus g t squared divided by 2, and we got no initial velocity. So this gives us a time of 4.041 seconds, and by subtracting 3.52, we get a final time of 0.521 seconds. There we go. Peace.